Just to prove this NCR equal to NC n minus R, we go by logical proof. Selecting R people from N is NCR, we know. If somebody says that this is equivalent to say not selecting N minus R people from N, then also it's fine. So NCR will be NC n minus R. Okay. Achha, number 1 done. Number 2, to prove that NCR minus 1 plus NCR equal to NC n plus 1 CR. We are not going for any mathematical proof. We are just trying to prove it logically how NCR minus 1 plus NCR can give us n plus 1 CR. So what I am doing here, I am considering a group of n plus 1 people. Out of these n plus 1 people, R people are selected. Then you will say that I have learned this formula in my school. So I can say that it is n plus 1 CR. This is equal to selecting R people from n plus 1. Now somebody says that no, it is not n plus 1 CR. It is in fact NCR minus 1 plus NCR. Why? He said that consider when you are selecting out of n plus 1 people, R people you are selecting, either you are selecting a captain of the group or not a group. If you are selecting a captain, is there. If you are selecting a captain, then the captain from n minus 1, n plus 1 people group, first you keep him out of the group. Then in the group, how many are there? N people. From n you select R minus 1. It can be done in NC R minus 1 ways. And then captain is added. So you get R people only. You need to select R people. There is a captain plus R minus 1 members. Now, people, those who are selected, they are telling that we don't need any captain. So then that captain will be thrown out of the team. How many are there in the team then? N people. From N you select R. So R people selected without captain. Without any captain, you have selected a team of R, or you have selected a team of R people only with a captain. So either or case, that's why these two cases are added. So selecting R directly from N plus 1 is similar to say selecting R minus 1 with a captain, or either or case means it will be added, or selecting a team of R people without a captain. Can be done both the ways. Okay. So these two easiest proof I gave you with the help of the logic of combination. Okay. Now, written to here, captain is there and R minus 1 members. So captain is one person and R minus 1. So R minus 1 plus 1 R people are selected. You need to select R people. And here you did not select any captain. So you have just selected R people out of N. So can be done either this way or that way. Okay. Now let us prove the first one, second one, third one, all discussion we can make afterwards because they are hurrying to leave the class. If we get stuck in one, then it will be yes. আমি তো শুনতেও পাচ্ছি না, বলো কি বলছো? তুমি লেখো ওয়ার্ডে, নাহলে হবে না। লেখো, let there be n plus 1 people in a group we are selecting r people out of these, all of you write, we are selecting r people out of n. It can be done in n plus 1 CR ways. But selection of r from n plus 1 people can be done by following method also. Number 1, selecting a captain and remaining r minus 1 from the group. Or number 2, selecting r from remaining n persons without a captain. In the first case, number of selections will be nc r minus 1, because when captain added to these r minus 1 people, we automatically get r members in the team. So your problem was selection of r, it is done. Or captain you don't need. All the members said that we don't need a captain. Then throw the captain out. Out of n plus 1, if captain is not there, how many are remaining? N. From there you select R. Either this case or this case will be there. That's why these two are added. NCR minus 1 plus NCR. But what you did there, you have selected R people from N plus 1. But directly also you can do, selecting R from N plus 1 people. So actually same problem we are thinking two different ways to prove the identity. Okay. This is the logic. Previous one, out of R you select, out of N you select R. Somebody says that, no, this is equivalent to say, out of N I am not selecting N minus R, because those who are selected are people, it's fine. But I'll not select you all. These N minus 1 are people, I'll not select you all. So two are same thing. Are people selected equivalent to say N minus R not selected? That's why N minus NCR was NCN minus R. This is the starting. Logically, if you develop the concept to prove some identity with the help of combinatorics, especially when it is in binomial identities like NC1, NC2, all these are involved, this is a great help. Let me tell you one by one, then I'll go for doubts clearing end. Okay? Let me prove the following without using this first one we are going to prove. Number 1, that sigma k equal to 0 nck 2 to the power n. How to prove it without using binomial theorem? I am saying that it is required to prove nc0, nc1, nc2, ncn 2 to the power n, nothing else. So what does nc0 means? Selection of no object out of n. NC1 means selection of 1 out of n. So left hand side will express what? Number of ways. This is equivalent to say number of ways of selection of people or object. Selection of an object from n objects, n different objects. Okay. Number of ways of selection of an object or not. May not be selected. That also true from n object. You will say that NC0, I did not select anything. I have 20 relatives, 20C0, I did not invite anything to my party. Or 20C1, I have invited one of them. Or 20. So out of those 20 guests, 20 relatives, how many ways you can select? You can invite none, or 1 or 2 or 3 or all 20 people in a party. It can be done NC0, NC1 this way. Somebody says that you think differently. For each people, selection can be done this manner. For the first person, either selected or not, it can be done 1 plus 1 way. Second person, either selected or not, it can be done 1 plus 1 way. Third person, either selected or not, it can be done 1 plus 1 way. This procedure will repeat n times. So this will give us 2 to the power n. So out of n people, you have selected 1, 2 or n or none. Can be done 2 to the power n ways. People say that I am fond of symbol. I'll write NC0 plus NC1 plus NC2 plus NCn. Fine. Okay. So these two are equal. Left hand side equal to right hand side. Think about second one. Number 2. NCk whole square equal to 2NCn. That NCk whole square sigma k equal to 0 to n. 2NCn. See how to prove this? Biologically, before I tell you anything, you just think how it can be proved. This left hand side, or before addition, we just check one thing. NCk whole square, NCk NC n minus k, isn't it? Because NCk and NC n minus k same thing. We have started the class with this identity. NCk equal to NC n minus k. So NCk square, I can write NCk into this thing. Therefore, if you say that sigma NCk whole square k equal to 0 to n is equal to sigma k equal to 0 to n, then it will be fine because you have written the same thing. Okay. Now think about the selection of n person from a set of, or n students from a set of n boys and n girls. I told you to think two different manner. We are selecting n out of these two n means we are selecting n out of n boys and n girls. So total number is what? 2n. From there n is selected. It can be done in 2n ways. But can't you say that it is similar to say I am selecting 0 from here, n from here, 1 from here, n minus 1 from here, 2 from here, n minus 2 from here, dot 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 dot, k from here, n minus k from here, dot 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 dot, n from here, and 0 from there. Okay, selection can be done this way also. You said out of 2n I'll select n only because you did not give me any restriction that you cannot select this many boys or this many girls. So simply I'll make the arrangement 2n cn ways. Somebody says that no, think differently. Why do you go for mathematical proof always? You think this way. When I'm selecting in 0 boys and n girls, how many ways it can be done? I'm writing here 0 boys and n girl. How many ways it can be done? 0 boys and n girl, this selection can be done nc0 into ncn ways. 1 boy and n minus 1 girls can be done nc1 into ncn minus 1 ways. 2 boys and n minus 2, it will be done in nc2 into, and k boys and n minus k, it will be and, isn't it? So these are all either or cases. Don't you put a plus sign when you are going to consider all the things together? Either this or this or this. See, if you make addition of all these things, what do you get? Here by adding you get that thing only, no? nc0 into ncn plus nc1 into ncn minus 1 plus dot 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 ncn into n. Okay, right, k. ncn minus k plus ncn into nc0. This is nothing but sigma k equal to 0 to n nck. And some of your friends say that you are fool, you are calculating this manner. Your problem was you selecting n out of 2n. How foolish you are, foolish activity you did, that you are calculating all these things here. Both of you are good in calculating. Both of you think different ways to get the answer. Here he or she might have taken longer, I mean many number of steps over there, but there is a beautiful logic. Here you are fond of getting a sum in 1 or 2 steps. You said that no, this is 2nc, just factorial 2n, but because you told me to select n out of 2n, I'll do this way. But listen, my task was to prove the identity, this identity. This is proved. So if you think differently, then identities in mathematics, particularly this chapter, can be solved. Okay, nicely. Let us go for proving the next one. That number 3. How to prove that 2 to the power k nck equal to 3 to the power n. Very good proof is there also. Just required to prove this thing, or let me simplify in the beginning. This we are required to prove. Okay, so you need to think different ways how to get it. This binomial proof, this is a textbook problem also, not only for entrance exam where you need to think really different manner. This is a textbook problem which we can do nicely with the help of logic, combinatorics logic only. Okay, we are thinking it bit different manner. Just you imagine that you have done the selection of k people from n. In how many ways it can be done? In ck ways. Number of choosing k person for a committee out of n can be done in ck ways. Now you have selected k people. You can this k must have values between 0 and 1. K greater than equal to 0, less than equal to n. Now you have selected n out of k. Those k people, you are selecting a subcommittee with those k people. Subcommittee means you are selecting number of subsets of k elements. Number of subsets of k elements going to be 2 to the power k. Okay. So what you are doing there, you are selecting k people and then forming a subcommittee. Okay. Now there will be 3 different choices for this. What are the choices? For each of the persons selected over, either he will be entering the committee, he is entering the committee, he is entering the committee and the subcommittee. Number 2, he is entering the committee but not to the subcommittee. Number 3, he does not belong to the committee and hence he does not belong to the subcommittee. So for each of the selected person, 3 options are there. Okay. So let us summarize the solution here. What I'm doing here, then this NCK solving this manner here, NCK stands for number of ways of choosing a number of ways of choosing of k elements from a set containing n elements. Okay, that k greater than equal to 0, less than equal to n, that I told you. This is the part of the solution. This is not given thing. But k must be greater than equal to 0, less than equal to n. Now, number of subcommittees 2 to the power k, number of ways subset you consider. Number of ways a subset can be formed. Okay, out of k elements. So what as a whole you did in this process? You have selected k person and formed a subcommittee. So selection of k person and then a subcommittee can be done together. Now think differently. Second way I am thinking. What the second way? That for a particular person, thinking different manner. Now for a particular element of the set, there are three options. I'm writing committee, then subcommittee. He is not belonging to the committee, then not belonging to the subcommittee. What other option can be there? He is belonging to the committee, not belonging to the subcommittee. Okay, then belonging to the committee and belonging to the subcommittee. So for a particular element of the set or subcommittee, no, we have taken it as subset or subcommittee, whatever. That subset we are not forming, we are doing subcommittees. Same thing. So for a particular element, there are three options. Therefore, for each element, there are three options. Therefore, number of ways selection can be made. How many? This is going to be 3 into 3 into 3. For each, there are three options. So this will be 3 to the power n. Here what you got? N ck 2 to the power k. This is for k. That k may be changing from 0 to n. That I told you earlier. K is changing from 0 to n. So here total number of ways of selection will be what? Total number of ways okay. So this is nothing but sigma k equal to 0 to n nck 2 to the power k. So these two are same thing. By now if somebody says that where is another proof, the proof is ready with you. So this binomial identity can be proved. Now I am going to prove one another